My name is Nick from student DE5A and from Polytechnic Kota Kinabalu. Today I want to present about Cmos integrated circuit design. The topic is doping. Doping process by which silicon atom in crystal lattice substratum silicon are replaced with atom dopant. Intentionally introduce impurity into an extremely pure semiconductor for the purpose of modulating its electrical properties. Phosphorus and arsenic are used to develop N-type silicon. Boron, gallium or indium used to develop P-type silicon. The function of doped layer: control the resistivity silicon, facilitate the flow of current carrier, and there is two method doping: one, thermal diffusion, and second, ion implantation. Thermal diffusion was accomplished by exposing the Si wafer to dopant, then driving it into the wafer at high temperature by diffusion. Two-step diffusion process: first is predeposition and second is drive-in.
Hello, my name is Harold Wood from student DE5A. Now I'm going to introduce you to the subtopic from doping, which is predeposition. The wafer is exposed to dopants, and the wafer is heated among temperature 1000 to 1200 degrees Celsius. The time, temperature, and amount of dopant are under control. The impurity will decimate or float above the surface. Next is the driving. No more dopant provided, and then drive the dopant on the E surface into the wafer to the desired depth by controlling the temperature and time. The advantage of the driving is ability to produce very high concentration of dopants into the polysil layer, attaining low levels of resistivity. The disadvantage of it is the high processing temperature and its tendency to increase surface roughness. The ion implantation has suppressed the diffusion in doping site. The next is the subtopic of ion implantation. They deposit dopants into the polysil layer by directly bombarding it with high-energy ions of the dopant species. This method can produce a shallow dope layer with high density of dopants. There's two parameters which can be controlled: exactly depth of area dope and density of doping material.
Hello, my name is Max Brandon. So now I'm gonna continue with the next slide. So as you can see from this slide is a magnetic mass insulation from outside view. So as you can see from this slide, this has a name of the path of the magnetic mass insulation. So from the front side and the back side has namely from the path of the magnetic mass insulations. So the next is, this is ion implementation. So as you can see from this slide has a 60 analyzed magnetic, neutral, beam trap, and beam gate, and also have a beam trap and gate plate. So it also has an ion source. So this is the view of the ion implementation. Okay.
My name is Marcellus from student DE5A. I will explain about the another characteristic of ion implantation. First is, high energy ions is planted to the silicon surface used to produce large-scale integrated circuit. This method can produce highly doped shallow layer. Depth and density are under control exactly, and dopant ion beam, bond or phosphorus is accelerated with high energy. Next is the advantage of ion implantation. First is the accuracy of dopants, position and density can be controlled with high precision. Next, thickness of dopant is uniform and use low temperature at room temperature. For this advantage, cause detect to crystal lattice based by dopant atoms. Second, high cost equipment and production of wafer is limited.